Hello everyone, welcome to the mathematical session. So today we will discuss straight lines concept and plane concept in 3D geometry of class 12. So let us go to the concept. Okay, you can see equation of a straight line in a space. So what do you mean by equation of a straight line in a space? Okay, so how the line is uniquely determined in a space. So when it passes through a given point and having a given direction, the meaning here is a point is there if at all a line passes and it is parallel to some given direction, then this we can say it as a straight line. The other one, it passes through the 2 points. When it passes through the 2 points, then we can say that it is a straight line. The first condition is the straight line passes through a point and having some direction parallel to some direction. One more is a straight line passing through the 2 points. Okay, these are the two ways, unique ways to determine any straight line. So I will draw the equation for the first one, passing through a point and parallel to a given direction and passing through the 2 points. Let us quickly go for the first derivation of an equation of a line. So here you can see equation of a line passing through a given point and parallel to a given vector. For that, first we need to draw a three-dimensional space, that is Cartesian system. So here I will take a point A, it's a position vector, let it be vector A. Okay, so a straight line passes through it, the straight line L just passes through it and parallel to a given vector. This is a given vector which we are having, parallel to a given vector having direction B. So that is B vector. Okay, now we will take some arbitrary point here P. Okay, let its position vector with respect to O be R. Okay, so here the point you will take it as A. Okay, so a line passes through a point A and parallel to a given vector. This is an arbitrary point, or you can say that it is a moving point on this line. Anywhere you can take this point P point, a general point. Here we are having origin. Okay, now let us write that the derivation, few statements we will write. Let capital A be a fixed point with position vector E, and line L passes through a point A and parallel to given vector B. Okay, let P be a arbitrary point, it is also called as moving point. Anywhere on a line you can take point with position vector R. Okay, so now then you can write it as, then AP vector is equals to OP minus OA vector. Okay, this implies, so OP is position vector of point P and OA is position vector of point A. Okay, since AP vector is parallel to B vector, okay, if AP vector is parallel to B vector, we can write AP is equals to lambda into B by parallelism, or from vectors. In vectors we have studied this. Now we will substitute the value of AP vector. Okay, now we will send this A to the other side. Vector R is equals to vector A plus lambda into vector B. So this is called the equation of a line. This is the equation of a line passing through the point A, which is having position vector small a and parallel to a given vector, vector B. Okay, so this is what the equation. So this equation is called vector form. Vector form of a straight line passing through a given point and parallel to a given vector. Okay, so this is what which we are having. Now in the next case we will see Cartesian form from vector form. Okay, so to derive a Cartesian form, let us take point A coordinates x1, y1, z1. Okay, coordinates of point P, it is a general point, we will take it as x, y, z. Okay, so and let A, B, C be direction ratios of vector B. Okay, so now, so vector A you can write it as x1 I, y1 j, z1 k. Okay, vector B you can write ai, bj, ck you can write, and vector R you can write xi, yj, zk. Okay, so now from vector form, it is vector R is equals to a vector lambda into a vector plus lambda into b vector. We will substitute all these ordinates, all these vectors in this equation. Xi plus yj plus zk is equals to x1i, y1j, z1k. Here this is a vector plus lambda into ai plus bj plus ck. Okay, so now we can write, so I terms are same here. Okay, I terms, so multiply lambda inside, so x1 plus lambda a into I plus y1 lambda into b j, z1 lambda into c k. Okay, so this implies x1i, y1j, z1k. Okay, so comparing the coefficients of ijk, comparing coefficients of I, j, k. Okay, what you are supposed to get here? So this implies x must be equal to x1 lambda into a, and y must be equal to, x must be equal to this part, and y must be equal to y1 lambda into j, and z is equals to z1 into lambda c. Okay, so this is what which we are having. Now simplify these terms with respect to lambda. Okay, so this implies lambda is equals to x minus x1 divided by a, lambda is equals to y minus y1 divided by b, and lambda is equals to z minus z1 divided by c. Okay, using these three equations we have seen a lambda value. Okay, here in all the cases lambda is equal, so this implies x minus x1 by a, y minus y1 by b, and z minus z1, okay, not and, it is equal sign, okay, z minus z1 by c. So this is nothing but whatever the equation you got, it is the Cartesian form of a straight line passing through the point x1 y1 z1 and parallel to a given vector whose direction ratios are a b c, okay. So this is nothing but Cartesian form. In Cartesian form, from vector form of a equation of a straight line passing through a point and parallel to a given vector, as we have derived the equation, so we shall have one note here, very important note, okay. So if L, M, N are direction cosines, okay. So previously we were using direction ratios. If at all direction cosines are given, then equation you can write like this. The equation you can write in this form using direction cosines of a line, okay. So instead of direction ratios, direction cosines are also given. The Cartesian form can be written as x minus x1 divided by L is equals to y minus y1 divided by M, and z is equals to z minus z1 divided by M, okay. This form also you can use during using direction cosines, okay. So thank you.